In the previous lesson, we saw how to do basic constructions, which are building blocks to most of Euclidean geometry theorems. We did construction 1, construction 2, construction 3, and construction 4. We are going to see how to apply some of these constructions to circle theorems. So today we want to look at circle theorem 1, which says a line drawn through the center of a circle to a chord bisects the chord. It means if we draw a line through a center of a circle and towards the chord to that circle, the line that we draw is actually going to bisect the chord. It's going to divide it into two equal parts. So given this circle with center O and chord AB, we want to draw a line that passes through the center, and it must be perpendicular, crossing this line at 90 degrees. So those are two conditions: through the center of the circle, and it has to cross line AB or chord AB at 90 degrees. Now, there are two methods that we can use here to make sure that the line passing through the center of the circle and crossing the chord will cross the chord at 90 degrees. Method 1, we can use compasses. Open our compasses to any convenient radius, and we are actually going to apply construction number 2 to draw a perpendicular line to a given line from a point outside the line. So instead of point P, we have point O. This is a point which is outside the line AB, which is the chord to the circle. So we can open compasses to any convenient radius, but making sure that we draw an arc to cross the chord twice. By so doing, we are establishing more construction points at the crossing points. So using those crossing points, we can open our compasses to any radius or use the same radius. We strike an arc this side. After striking the first arc, we don't change the radius. Then we change the compass point position to that crossing point. We strike another arc. Now these two arcs cross each other in this point. Then we should now draw a line, a straight line, passing through this crossing point and the center of the circle. This line will for sure be a perpendicular line to chord AB. Now we have to check. What we have done here is to draw a line through the center of a circle to the chord, which is this line, this red line. Now, does it bisect the chord? The letters in black. We can check with dividers or even with a ruler. If I put a ruler here, then I can see that it's about 3 centimeters. Now, and here it's also 3 centimeters. So we are basically saying AB has been divided into two line segments, which is AE and BE. So AE is about 3 centimeters and BE is also 3 centimeters. So we can now indicate with the short lines that line segment AE is equal to line segment BE. So what we've done is in red, and the results is in black, the bisection of the chord. So this is method 1. To use method 2, we may not use compasses, but we can use two set squares. If I've got a set square, another set square, or we can use a set square and a straight edge like a ruler. So the first thing that I can do is to place the set square along chord AB, knowing that this is the center of the circle O. So I put the set square accurately along chord AB. So bring a ruler to the set square so that the ruler and the set square will guide each other. When we move one instrument, the other one should remain stationary. It mustn't move even the slightest. If it moves, then we have to start afresh. So I can slide the set square to open up space, which I can use for the ruler. So the set square comes to a stationary point, then I'm free to move the ruler, and they should always be in contact, no space between the ruler and the set square. So now once the ruler is in position, I can press it in position and I'm free to move the set square. Because the set square is an angle of 90 degrees, there is 90 degrees in this angle here. Now I'll be able to use it to draw and get a line at 90 degrees to the chord. So through the center of the circle, I can draw a straight line. Okay, so this line here, when extended, is through at 90 degrees. So it creates an angle of 90 degrees here, just like the first one. So the red line is at 90 degrees to the chord. We can call this point E. Now, if we check with dividers, we can see that AE is equal to BE. So these two are two line segments that are equal. So we can safely say EB is equal to EA. So this is the second method. This is method 1. This is method 2. Okay. So this is theorem 1. Now looking at the application, one application question. This question says, given a circle with center O and chord EF drawn so that GH passes through center O. Now, there is a circle, center O, and there is chord EF. Now, GH is this red line here. It's passing through center O, and it's said to be perpendicular. GH is perpendicular to EF. GH is perpendicular to EF. And the 90-degree angle is indicated with a small square. So we are given the first condition of this theorem. Now, the second the second condition is the result. But we are also told that EF is equal to 12 centimeters, EF is equal to 12 centimeters, OG is equal to 4 centimeters, OG is equal to 4 centimeters. Now, what we can do is to write some of the information on the given diagram and also do some constructions, even if you are not told to do those constructions. Now, the question says, with reasons, determine the radius of the circle. B, with reasons, find the length of GH. So some of the information given in the question can be written on the diagram, like 4 centimeters. 4 centimeters, we can write it there because it's given. Now, if EF is equal to 12 centimeters, we can actually say, let's draw a line from E to O. That's an additional construction so that we complete a triangle there. And this triangle EOG is a right angle triangle. We can also draw a line from O to F. We complete another right angle triangle OGF. So this is an additional construction that is necessary. Now, it will enable us to allow us to pick a triangle. I can say in triangle OGE. Now, in triangle OGE, then I say EG, because EG is equal to FG. Then I can say GE is equal to 12 centimeters divided by 2, which is equal to 6 centimeters. What is the reason? We can say GH is perpendicular to EF is the reason. So that's the reason there. GH is perpendicular to EF, and we can say it passes through O. It passes through O. That's the first reason. So I can come and write 6 centimeters in the diagram. So 6 centimeters, so that I see properly, I am able to visualize. Now, if we look at triangle OGE is a right angled triangle, we can now apply Pythagoras theorem. So to find the radius, OE is the radius and OF is also the same radius. OH is also the same radius. So the radius of the circle doesn't change. So I can write r squared is equal to x squared plus y squared. So r squared is equal to 4 squared plus 6 squared. R squared is equal to 16 plus 36. R squared is equal to 52. We don't forget the reason here. The reason here is Pythagoras. We can say Pythagoras theorem. Now, this is a square on the left, r squared. This is a square on the right. So we find the square of each side. So the square root of r squared is r. Then this is equal to the square root of 52. Now, we can see that this is equal to the square root of 4 times 13. Now, the square root of 4 is 2, so we can put out the square root of 4 outside the root sign. So we can find this, we can leave it as 2 root 13. Now, if we put it on our calculator, we can see that maybe it's 7 something or 7.25. Okay, right. So once we get that, we know the radius is equal to 7, we know the radius is equal to 7.21. So with our calculator is 7.21 centimeters. So that's the radius of the circle OE. Now, the second question, this is actually question A. Question B says, determine with reasons the length of GH. Now, GH is part of the radius, okay? So we can now start by saying OH is equal to 7.21 centimeters. Then the reason is actually the radius of the circle. So once we have that, we can say OG plus GH is equal to 7.21. But we know OG, which is 4. We don't know GH. This is equal to 7.21 centimeters. So GH is equal to 7.21 minus 4, which is equal to 3,21 centimeters. So this is how you can apply circle theorem 1 so effectively. It depends on the question that is given. Now, there are two things here. Either you are given a line passing through the center like this and is perpendicular, or we are told that the chord is already divided into two equal parts. Then you need to know that if that is given first, then the line passing through the center is actually at 90 degrees. So one of the two is going to be helpful as a reason. It will be given as a reason in the question, because we mustn't forget to give the reasons when we are solving the problems. Thank you. See you in the next lesson, and we are going to look at theorem number 2 in Euclidean geometry.